All right, so in this video, I'm going to talk about series and parallel equivalents for capacitors. We talked about these for resistors. For capacitors, it actually turns out that, oh, I'm on the wrong tool. The parallel equivalents are actually the easier of the two to perform the arithmetic for. If I have two capacitors in parallel or n capacitors in parallel, let me just draw these out. If you need to review what it means for something to be in parallel, go back to module 1. And so let's say that these are my capacitors in parallel. Let's say I've got C1, C2, all the way out to Cn. All right, well, what I need to do is simply add them up to get the equivalent capacitance. So if I were to draw my little blue box and I want to replace all these capacitors with one equivalent capacitance like this would be my C equivalent, and that would be equal to C1 plus C2 plus all the way out to Cn. You just add capacitors in parallel and that gives you the equivalent capacitance. Okay? So this is the opposite of how resistors in parallel work, right? Resistors in series add, capacitors in parallel add, okay? And so if I have series capacitors, so something that looked more like this, then these behave the way that resistors in parallel behave. So again, I'll call this C1, C2, and Cn. And so if I wanted to take this group of capacitors here and I want to replace it with a single equivalent capacitor, CEQ, that CEQ is going to be equal to, 1 over that CEQ is going to be equal to 1 over C1 plus 1 over C2 all the way down to 1 over Cn. So this is exactly how resistors in parallel add. It's the same way that capacitors in series add. Okay, so whatever you know about resistors, hopefully you know it well by now. All you have to do is flip it to find equivalents for capacitors, okay? And so let me go one step further. If we recall the special case for capacitors, for resistors where you just have two of them, you can use the product over sum equation to find CEQ, which is C1 times C2 over C1 plus C2. I already derived this in module 1. I'm not going to derive it again, but just to remind you that if you only have two in series that you need to add, you can always use this equation, which is basically just the simplified form of this equation, right? Just solving for CEQ in this equation. All right, so with that, I'm going to wrap this video up, and in the next video, I'm going to talk about charge sharing.